Welcome everyone to page 6 of the fall semester 2014 final exam for Math 234. In this page we want to evaluate a few integrals here. So I have a nice double integral, and hopefully you've tried this one out and you've seen that, try as you might with all of our different techniques of integration and whatnot, this one's quite difficult to integrate as it sits. And so when it's quite difficult to integrate, we think about, well, what happens maybe if we were to switch the order of integration? So in order to switch the order of integration here, it's really useful to sketch out a picture. So let's go ahead and sketch out a picture really quick. We can see that for the dx, right, the x values, they're ranging from 0 to 1. So I know my picture is going to be somewhere in this region right here from 0 to 1. And let's see, as I travel up in the y direction, first I come across y equals x. So y equals x is going to be something like this. So that's how I enter into the region. And then I exit through the region at y equals 1. So y equals 1 is maybe just a nice horizontal line here at height 1. Alright, so this right here is the region that we're integrating over. Again, it's kind of between x equals 0 and x equals 1. And we enter in through y equals x, and we exit through y equals 1. So there's our picture. So switching the order of integration here, that means we're going to have, let's see, dx first and then dy. Of course, the function that we're integrating stays the same, so e to the x over y. And so let's see, now if I'm traveling in the x direction first, I'm going to enter in through the straight up and down line right here, so that's going to be x equals 0. We're going to exit through the green line, and remember that has the equation y equals x. So the x value of this, right, x equals y. Alright, so I'm going to go ahead and put a y here. And then let's see, if I was to smash this down so that there were no more x's in the world and all that was left were y's, the y's would range between 0 and 1. Alright, so that's me setting it up in maybe the opposite order of integration and whatnot. So let's go ahead and integrate this with respect to x. So if I integrate this with respect to x, well, let's see, I'll still have this integral with respect to y hanging out there. The 4, again, will be hanging out. And so when I integrate e to the x, remember we have this 1 over y we assume like it's like a constant, right? It's just along for the ride here. So I integrate 1 over x, I'm going to have, e to the x, I get e to the x. And now be careful because we have this nice constant here. And so we should multiply by the reciprocal of that constant. So the reciprocal of 1 over y is just going to be y. Alright, let's be a little bit paranoid though and see if we made any mistakes, right? If I take the derivative of this, do I get back to where I started? So I'm going to take the derivative of x. Well, the derivative of e raised to anything, right, is just going to be e. Leave the inside alone, check. And then you take the derivative of the inside, and so that's going to be 1 over y. So 1 over y times y, perfect, that goes away, and so we just get 4e to the x over y. So again, we can always use the derivative to check our antiderivative. Alright, now let's go ahead and plug in 0 and y everywhere we see an x. So I'm going to have 4y e to the, let's see, when I plug in y, I'm going to have y over y, that's just going to be 1. Subtract away, when I plug in 0 everywhere I see an x, that's going to be e to the 0, that's just going to be 1. Alright, so this is some constant here. Also, 4 is some constant. Let's go ahead and factor out all of these constants here. So 4e minus 1, and then I'm going to have the integral from 0 to 1 of just good old y. And so let's see, I'm going to have 4e minus 1, and when I integrate y, I'm going to get 1/2 y squared, and then I'm going to plug in 0 and 1, which will just give me 1. So when I multiply by 1, of course, there we go. So this is our final answer. Or if you want to be even better about simplifying, right, the 1/2 and the 4 do cancel, and you get 2 times e minus 1. So either one of these, I'd give 100% for. You can also distribute. Again, I'd give 100% for that as well. Okay, let's go ahead and move on to the second problem on this page. Let's see, we want to integrate. We have 2 cosine of x squared plus y squared dy dx. Alright, let's go ahead and take a look at this region here. Again, if you were to just start trying to integrate this, integrating with the cosine of x squared plus y squared here with respect to y, that would be very difficult. So I'm going to try to figure out if there's a trick here. And so I'm going to graph this region and see what's going on. Alright, so we draw a nice picture here. Again, if I'm looking at maybe the x's, we see x's range from 0 to 3. So 0 all the way to 3. This is where my picture is going to live here. And let's see, as I'm traveling in the y direction, I enter into the region through y equals 0. So that's going to be this nice horizontal line, aka the x-axis here. And I'm going to exit through y equals the square root of 9 minus x squared. So that's going to be y equals the square root of 9 minus x squared. Maybe you've seen these things so many times that you already know what it is. But if you don't, right, we're going to square both sides. We're going to add x squared to both sides. And now hopefully this makes you remember that it's a circle, right? So it's a circle of radius 3. But we're only looking in this region right here, right? So in between 0 and 3 here, right, there would be a top half of the circle and a bottom half of the circle, right? So there'd be something up here and there would be something down here. And we have to decide, well, which do we want, right? Well, because it's the positive square root, right, positive square root, that means that the y values are going to be positive. So they should be above the x-axis, right? Here's where the y values are positive. So we want the positive square root, aka the top half of the circle. So this is the region that we're integrating over here. And because it looks awfully circly, right, I'm kind of naturally thinking about polar now. Which also, I mean, we see an x squared plus y squared, so we were probably already thinking about polar, but now especially. So let's go ahead and maybe transform this into a polar equation. So I'm going to have, let's see, 2 cosine of r squared. And instead of dy dx, I'm going to put r dr d theta. My r values range between 0 and 3. And my theta values range between 0 and pi over 2. So here's the hard part, really the setup. Now let's go ahead and do the integration. So when I integrate, notice that I have something with just r's in it. We don't have any theta values or anything like this in the limits of integration. There's no thetas whatsoever. So I'm going to go ahead and evaluate out my theta integral really quick. And this is just going to be, well, when you integrate 1 with respect to theta, you get theta. When you plug in 0 and pi over 2, we're just going to get pi over 2. So that's relatively nice here. All right, now we're going to go ahead and try to integrate this bit, right, the bit with the r's. So I'm going to try this, and then I'm going to plug in 0 to 3. So let's see, formally we would do this with a u substitution, maybe where u is equal to r squared. And then you'll notice, right, that you have a 2r dr, right, that's going to be your du value, all that good stuff. Or you can do kind of a guess and check method. I'm going to try maybe sine of r squared first and see if that gets me the correct derivative when I take the derivative of this. So when I take the derivative of this, I would get the derivative of sine is cosine, leave the inside alone, check. So this bit's there. And then when you take the derivative of the inside, you get 2r. So 2 and the r. So yes, the antiderivative should be sine of r squared. And so now we can go ahead and plug in these values. So I get pi over 2 times sine of, let's see, 3 squared would be 9, minus sine of 0 squared would be 0. So actually, let me just leave that out. So my final answer here is going to be pi over 2 times the sine of 9. Nothing more we can do to simplify that. There we are. Okay, that's it for this video. I'll see you guys next time.